In this video, I'm going to show you how we can find integral of functions with the integration by parts. This is the formula of integration by parts. Integral of u times dv is uv minus integral of v du. You have to memorize this formula for finding integral of functions with the integration by parts. But the difficulty that the students usually have is that when we have to find integral with this method. Integration by parts is ideally suited when you want to evaluate integrals of products of functions. For example, when you want to find integral of x cosine of x dx, or integral of x times by e to the x dx, or integral of x squared ln of x dx. You can find all of these integrals with integration by parts. Note that all of these functions are product of two different functions, x times cosine of x. In the second one, x times by e to the x. And in the third one, x2 times ln of x. Another case that integration by parts works very well is when you have a single function like ln of x or sine inverse of x or tangent inverse of x. We cannot find these three integrals with other methods. When you want to find integral of a single function like these examples, which we don't have any formula corresponding to them in the integration formulas, we can find these integrals with the integration by parts. So integration by parts works well when you have products of two functions or you have a single function like these. Now let me show you an example to see how we can use this formula for finding integral of functions. Integral of x times by cosine of x dx. This example is the product of two functions, x and cosine of x. To use this formula for finding this integral, first we have to choose u and dv. In the integration by parts formula, we choose u such that the derivative of u be a simpler function. In this particular example, we have x and cosine of x. Which one of these two functions can be u? If we choose x to be u, the derivative of x is 1. If we choose cosine of x to be u, the derivative of cosine of x is negative sine of x. When we take the derivative of x, we get to 1, which is a simpler function. But when we choose cosine of x to be u, the derivative of cosine of x is negative sine of x, which is not really a simpler function. So in this example, we choose x to be u. After we choose u, the other part of the expression in front of the integral is dv. And so dv is cosine of x dx. So a part of this integral is u and the other part is dv, completely similar to our formula. A part of the integral should be u and the other part dv. After we choose u and dv, we have to find du, which is derivative of x 1 times by dx. So du is dx. And from dv, we have to find v. To do so, we have to integrate from both sides of this relation. Integral of 1 dv, we can suppose that you have a 1 here. Integral of 1 dv is v. Maybe you ask yourself why we have to find v. Note that in the integration by parts formula, we need v for here and here. So we have to find v. And now if we integrate the right side of this formula, integral of cosine of x dx, sine of x. Now everything is ready to use this formula to find our integral. Based on the formula that here we have, the integral of u dv, the given question, is equal to uv, which means multiply u by v. U is x and v is sine of x. If we multiply u by v, we get x sine of x minus integral of v, which is sine of x. Note that v is sine of x, times by du, and du is dx. Now if you look at this new integral, which we have here, integral of sine of x dx is simply negative cosine of x from the integration formulas. We know that integral of sine is negative cosine. So we can write our answer as x sine of x. We write this part again, minus, again integral of sine is negative cosine, so integral of sine of x dx is negative cosine of x, and don't forget to put c in the end. If we multiply this negative by this negative, we can write our answer as x sine of x plus cosine of x plus c. And this is the answer of this integral. Integral of x cosine of x dx is x sine of x plus cosine of x plus c. Let me show you another example. We want to find integral of x times by e to the x dx. Again, first we have to choose u and dv. This is the process that we do every time that we want to find integrals with integration by parts methods. In this example, similar to the previous example, we choose u to be x and the other part we choose to be dv. The reason that we choose u to be x, not e to the x, is that derivative of x is 1, but derivative of e to the x is e to the x. And as I mentioned before, choose a part of your integral to be u that derivative of that u is a simpler function, which in this case x is that function. Derivative of x is 1, but when you take derivative of e to the x, it's again e to the x, which is not a simpler function. Now that we choose our u and dv, we have to find du, which is again dx, and we have to integrate from both sides of this relation. Integral of 1 dv is v, and integral of e to the x dx is e to the x. Now everything is ready to use this formula for finding this integral. Based on our formula, this integral is equal to uv, u times v, u is x, v is e to the x, so x times e to the x minus integral of v, which is e to the x again, times du, du is dx. We know that integral of e to the x dx is e to the x, so we can write our answer as x e to the x minus e to the x plus c. So the integral of x times e to the x dx is x e to the x minus e to the x plus c. The hardest part of the integration by parts is choosing u and dv. Let me show you a trick that can help you in finding u and dv. You can use this acronym LIATE, L-I-A-T-E, which L stands for logarithmic functions, I for inverse trig, A for algebraic, T for trigonometric, and E for exponential functions. logarithmic functions like ln of x, inverse trick like sine inverse of x, arc tangent of x, algebraic like x, x to the 2, and so on. Any polynomial. Trigonometric functions like sine of x, cosine of x. And finally, exponential functions like e to the x, e to the 2x, 10 to the x, etc. When you want to choose u, look at this list and choose u, the first function that appears in this list. Let me show you by an example how this acronym works. Suppose we want to find integral of x times cosine of x dx. In this case, we have x, which is an algebraic function, and we have cosine of x, which is a trigonometric function. Between algebraic and trigonometric function, which one appears first in this list? As you can see, a appears before t. So we choose u, the algebraic part, x, and the other part of this integral will be dv. So we choose dv to be cosine of x times dx. Don't forget, always when you choose dv, dx will be the part of dv. Let me show you another example. Suppose you want to find integral of x squared times by ln of x dx. X squared is algebraic. Ln of x is a logarithmic function. Between L and A, which letter appears first in this list? Because L comes before A, so we choose u ln of x, and the other part of this integral will be dv. So dv is x squared dx. So you can use this acronym when you want to choose u and dv in the integration by parts. Here we want to find integral of x minus 2 times sine of x dx. X minus 2 is an algebraic function, and sine of x is a trigonometric function. And because a comes before t, so in this example u is the algebraic part and the other part will be dv. So we choose sine of x dx as dv. As usual, from u we take derivative, and du will be derivative of x minus 2. Derivative of x is 1, derivative of 2 is 0, so derivative of x minus 2 in total is 1. Don't forget to multiply by dx, so 1 dx or simply dx. From dv we have to integrate. What is integral of 1 dv? V. And integral of sine is negative cosine of x. Now everything is ready to use the integration by parts formula for finding this integral. So the integral is equal to u times v. U is x minus 2 and v is negative cosine of x. So x minus 2 times negative cosine of x minus integral of v, which is negative cosine of x, times du, and du is dx. Now if we cancel the negative in the integral with the negative outside of the integral, integral of cosine of x dx is sine of x. So we can write our answer in the form of x minus 2 times negative cosine of x plus integral of cosine again is sine of x plus c. And this is the answer of this integral. Another example. Here we want to find the integral of ln of x. ln of x is one of the most important functions in mathematics, and so integral of this function is also important. Based on the LIATE rule, because the only function that here we have is a logarithmic function, ln of x is a type of logarithmic function. So we choose ln of x as u, and the other part, which is dx, will be our dv. Note that here we have only one choice. ln of x is the only function that appears in this integral. So we choose that part as u. We choose u ln of x and dv dx. From u we take derivative. Derivative of ln of x is 1 over x. And from dv we take integral. Integral of 1 dv is v, and integral of 1 dx is x. Now if we use the integration by parts formula, this integral is u times v. U is ln of x times vx. So ln of x times x minus integral of v, which is x, times du, and du is 1 over x dx. Note that x times 1 over x is 1. We can cancel x from the top with x from the bottom, and only 1 remains. And integral of 1 dx is x. And the integral of 1 dx is x. And so the answer is ln of x times x minus x plus c. It's a good idea to rewrite your answer in this form. Instead of writing ln of x times x, write it as x ln of x minus x plus c. Note that between ln of x and x is multiplication, and we can change the order in the multiplication. So integral of ln of x dx is equal to x ln of x minus x plus c. In this question, we want to find integral of tangent inverse of x dx, one of the other important functions in mathematics. Because the only function that here we have is tangent inverse of x, we choose tangent inverse of x as a u, and the other part, which is dx, will be our dv. So u is tangent inverse of x, and dv is dx. As usual, immediately we take derivative of u, which is 1 over 1 plus x squared, and don't forget to put dx in the end. And from dv we take integral. Integral of 1 dv is v, and integral of 1 dx is x. Now we can use the integration by parts formula to find this integral. So the integral of tangent inverse of x dx is equal to u times v. U is tangent inverse of x times v, which is x. So tangent inverse of x times by x minus integral of v, which is x, times du 1 over 1 plus x squared dx. So x times by 1 over 1 plus x squared dx. But note that x times by 1 over 1 plus x squared is actually x over 1 plus x squared. Because note that you can put a 1 in the denominator of x, and when you want to multiply these two fractions, x multiplies by 1, which is x, and 1 times this denominator will be the same denominator. So here, instead of writing x times by 1 over 1 plus x2 dx, we can put x over 1 plus x squared dx. Now for finding this new integral of x over 1 plus x squared dx, we need to do a simple u substitution. If we choose the denominator of this expression as u, derivative of u will be 2x dx. And if we solve this relation for dx, we get du over 2x is dx. Now let's write this integral in terms of u. Instead of the denominator 1 plus x squared, we put u, we leave x in the top, and we replace dx with du over 2x. So we have du over 2x. Now if we cancel x from the top with the x from the bottom, we get to this integral of du over 2u. Because 2 is just a coefficient in the integral, we can pull out these 2, and so this equals to 1/2 integral of du over u. We know that integral of du over u is ln of u, or ln of absolute of u, plus c. But u was originally 1 plus x squared. So this equals to 1 over 2 ln of absolute of 1 plus x squared. Now that we evaluated this integral, the integral of tangent inverse of x is equal to x tangent inverse of x minus 1/2 ln of 1 plus x squared plus c. Note that it's not necessary to put absolute around 1 plus x squared, because 1 plus x squared is always positive and you don't need to put absolute around that. So in this example, we experienced something new. After we did the integration by parts, for finding the new integral, we used a u substitution. As the last example in this video, let's solve this integral of x squared times sine of x dx. For finding this integral, we have to do integration by parts twice. The reason is that here we have x squared, and when you have x squared times by a trig function or times by exponential function, you have to do integration by parts twice. And if we have x to the power of 3 times by trig or exponential function, you have to do integration by parts thrice, and so on. Because in this example, x2 is algebraic and sine of x is trigonometric function, we choose x squared as u because algebraic appears first in the list, and dv will be sine of x dx. Now we have to find the du, which is 2x dx, and by integrating from dv, v is negative cosine of x. Integral of sine is negative cosine. Now if we use the integration by parts formula, this integral is equal to u times v, x2 times negative cosine of x, which we can write it as negative x2 cosine of x minus integral of v, which is negative cosine of x, and we can cancel this negative in the front of cosine of x with the negative outside of the integral and make this positive. Cosine of x times du, and du is 2x dx. Now for finding this new integral, we have to do integration by parts again, because we have an algebraic function multiplied by a trigonometric function. Again, we choose the algebraic part as u, so u is 2x, 2x is algebraic, and cosine of x is trigonometric function. So we choose the algebraic, which appears before trigonometric as u, and the other part of this integral will be dv. So dv is cosine of x dx. Again, from du we take derivative, and derivative of 2x is 2. Don't forget to put dx in the end. And from dv we take integral. Integral of dv is v, and integral of cosine of x is sine of x. Now we use the integration by parts formula again for finding this new integral. So we write negative x2 cosine of x again plus uv, then u and then uv. Don't forget, now u is 2x and v is sine of x. U times v, so 2x times sine of x, minus integral of v, which is sine of x, times du, and du is 2 dx. Instead of writing 2 dx, I'm putting dx in the integral and 2 outside of the integral, because 2 is a coefficient, and always we can put coefficient outside of the integral. And finally, the answer is negative x2 cosine of x plus 2x sine of x. Integral of sine of x dx is negative cosine of x, and if you multiply negative cosine of x in the negative 2, the answer is plus 2 cosine of x plus c. And so this is the answer of the given integral. Integral of x2 sine of x dx is negative x2 cosine of x plus 2x sine of x plus 2 cosine of x plus c. I hope you enjoyed this video. If you like this video, please subscribe, and see you in the next videos.